Hey guys, welcome to a new video. I'm really happy to have you here. Before we begin this lesson, I would like to talk about two things. First one is that I have a new newsletter, that's hard to say, and where I share cool links that I found throughout the week, share my blog posts, my new videos, ask for some ideas of videos, and I'm also going to release a free test-driven development course in the next few weeks. If you'd like to have some early previews, I would also like to ask you for feedback and all of this stuff. You can subscribe to the list in the description. It would be really cool if you could do that, and I would appreciate it. Second thing is, if you want to support me to continue doing this kind of videos, all I ask is for a subscribe and a like. And if you like, you can share this with a friend or with a community that you think would be helped by this content. But anyway, today we are going to talk about swappable implementations, and although the name is a little bit fancy, it's actually a very simple concept. It just means that you have an implementation and that you can swap it for another implementation while keeping the same public API. So let's work with with one example. You have two payment gateways, let's say Stripe and Braintree, and you have your website serving users and the US and Russia, or let's say Brazil and the US. And you want clients on the US to pay using Stripe and clients in Brazil to pay using Braintree. So you have two implementations. And what I see lots of beginner to intermediate developers do is put a lot of if blocks, a lot of conditionals in their code, instantiate different kind of services. It's really a little bit messy. And it's just not easy to maintain. It's not easy to look at. You can just really figure what's going on. And with a swappable implementation, you can have a single API, so a single public API. So if you call a method called pay, you can always call that. And you can have your system, your application resolve the correct dependency for you automatically, the correct implementation. So if your client needs Braintree, it will get you the Braintree provider. If it wants Stripe, it will get you the Stripe provider. All automatic. And you only have one single clean API. You don't really care what gateway you are using. The system will determine that for you, and you just use the correct implementation. I'm also going to talk about the repository pattern, but on another video. It kind of depends on this one. I just want to lay some foundation. But anyway, let's jump into the code and I can explain it a little bit better for you guys. See you later. See you in a sec. Okay, so here we have kind of a task controller. Just want to show you guys how it works. And we are just calling this Stripe class. It's all fake. I created a Stripe and Braintree class to just server purposes. And we are calling this class in pay. So what you would usually do in your controllers is say, hey, if we don't have a user authenticated, but let's just write some pseudocode. As in Brazil, something like that. Then we want to say, I don't know, generate Braintree payment. And if the user is on the US, which is the only other possible place, you can say, hey, generate a Stripe payment. And then you have a bunch of duplicated code, all that stuff, and then you just your actions. What we want to do is to have a clean API and use that for all the implementation. So what we want to do is something like that. Say gateway. I'm going to show you guys two things. The first one being the factory pattern, and then I'm going to show you guys something called dependency injection. And also letting the container resolve things for us. If you do not know what the container is, I'm using Laravel in this example, but Symfony has a container as well. Lots of frameworks have it. And you can check the documentation. But it's basically a place where the application holds all of the available classes, and it resolves the classes for you. So when you say, hey container, resolve me the payments controller, it's going to search for that class. If it's not inside the container, it's going to pull it and then give it to you. But it allows you to do a lot of things. For instance, you can say, hey container, when a class asks you for the payments controller class object, don't give them the payments controller object. Actually give them the receipts controller class. So you have that option. You can kind of give it you can I don't know how to say this. You can basically bind things to the container, and you can say, I don't know, container, when someone asks you for a contract for an interface, and you know that you cannot instantiate an interface. When someone asks you for the payments interface, actually gives them the Stripe gateway, something like that. I'm going to show you guys. So the first thing is the factory pattern. And what you could do here is you could say gateway, factory, and then you could, even better, for user and then you could say, I don't know, user country, something like that. Let's write this class just to give you guys an example, and let's just pass a hard-coded value here. Let's say Brazil, and let's just return that gateway so we can see a little bit. Whoops, let me go back to it. So I'm going to create a class called, where did I create this one? So I'm going to create a class called gateway. Let's do a static function. Let's just say for country. We can change it. Country. Let's change this. Okay, let's import this class. So we have this method, and what we can do here is just say if country equals Brazil, we return a Braintree instance. And why is this? Oh, oops, wrong name. Okay. If it's not Brazil, we just have the US, so you can just return a Stripe instance. And what we are seeing here is that the controller does not really care for which type of instance it is. It will just it doesn't care. It's asking for this gateway class. Whatever the gateway class gives it, it's just going to use it. So we can do payment gateway. Let's pay an amount of 100, and let's return an array so I can show you guys the difference. What it returns? Okay, it returns an array. So if we go to Chrome and we run this, I don't know what this is empty. Oh, I'm not. Let's dump and die this actually. And you can see that we have a Braintree instance here and the array that it returns. But if we were to give a user living in the US, it actually gives us a Stripe instance. So that's pretty basic. That's the factory pattern. That's really useful. You're going to use that a lot probably. But we have a small issue here. So we're calling this pay method, but we cannot be certain that the class has that pay method. We are not sure about that. And what we can do to kind of go around this is to add a contract, an interface. So let's create an interface. Let's do a contracts folder. So let's say payment gateway. So let me copy this, contracts, and we can do interface payment gateway. It needs to have a pay method, and it should return an array, something like that. There we go. So we're saying that it needs a payment method and it should return an array. Okay, cool. So we can say implement payment gateway, and the same for Stripe. Let me just copy this and put it here and pull this class. So what we are seeing here is that we are not following the interface. We are not following the contract. We have changes. So this enforces that we have the same API for all of the objects. We don't have to worry about this. Let's change it. I forgot to add that it has an integer amount, and we'll still get this error. So let's say we are supposed to return an array. So let's say array, and the same on Braintree. Let's return an array. And now it works. And now we can be sure that we are getting a proper object and that it follows the API. Actually, we cannot do that yet. We would need to add a return type here. We can say that we want to return a payment gateway. So we are enforcing this, and it still works. If I were to, we are getting Stripe, right? So if I were to go here and remove this, oops, it's going to fail because we are not returning an instance of payment gateway. It is not implemented. So that's the first thing I wanted to talk to you guys about. That's a really useful pattern, and you can do a lot of things with it. You can check for a property inside a model. You can check for environment configuration, so you may have the app deployed into different instances, and you can have an environment variable saying it should use Stripe, or that it should Braintree, or anything like that. And we are actually going to use something similar to use the repository pattern, but that's a subject for another video. And another thing that we can do is there's something called dependency injection, and that's basically not instantiating the objects like we are right here, not using new. We ask someone to give us a dependency, something like that. We can do a construct. Let me actually do a shortcut. And we can say gateway. Let me just change this to protected. And you can say, let's even type hint this and say that we want a payment gateway. And I'm doing this in the wrong class. Sorry about that, guys. This video is a mess. We're supposed to do this here. And you may think, okay, that's cool, but on Laravel or Symfony, or I believe any framework, you do not actually instantiate the controller. So how can we pass an argument to the constructor? And here's where the container shines. You do not instantiate it, but Laravel does, or Symfony, or Zen, or any framework. And you can instruct the framework to give you a certain instance. Let's try running this. Let's change this for this. Let's use that argument and change this here as well. And if we run this, we're getting an error. After all, payment gateway is a contract. It's an interface. It's not instantiable. And what we can do is instruct the framework to give us the proper class. So we can go and say, go to, let's say, app service provider, go to boot, and we can do something like that. This app bind. So we are binding, and we can bind the payment gateway interface to give us, let's say, Stripe. Let's try it. And now we are getting Stripe. And if we say Braintree, it give us Braintree. And you can go even further, and you can say, I don't know, if we are in Brazil, if this, let's say you have an environment, you have a configuration. So you can say if app.country BR, then you can bind this payment gateway to Braintree. If it's not Brazil, you can bind it to something else. And this is really, really flexible. You can do lots of things with it. I'm giving you guys a really small example using two payment gateways because that's something that I'll have to do in an app that I'm working on. So it's the most, it's the example that I got right now. I've used this. I use this all the time, but it's just the first example that came to mind. And I think that most of us can relate to. But this is a really, it's a really important thing to know this. It gives you a lot of room to do lots of things. So when we do this, we are saying that a container should always inject Braintree class when we ask for a payment gateway. And this is not limited to classes, because what this is actually doing is passing a string. And take a look at this. If I go ahead and remove this, and I call for this class manually, and I can do it like this. Let me just change this to gateway. there's a method called resolve. So we can say resolve payment gateway. It's the same thing that we were doing earlier, but just manually. The controller is not injecting it. And if we run this, we still get a Braintree. But you can also use this for other things. It doesn't have to be an implementation. You can, I don't know, you could say gateway. You can pass a string. And if we say gateway, and we run this, we still get Braintree. So the container is not actually looking for a class, but for a string inside of its resolved classes. So when we say payment gateway class, we're actually just doing gateways, payment gateway. That's what we are saying. So this approach works for a lot of things. It's not just that just what I'm showing you guys. It's not just dependency injection. Dependency injection is not actually this, but the concept that I showed earlier, where you don't actually instantiate objects in the class. Instead, you receive them. And I also want to talk about why that's useful. Let's say you are doing, let's say we're back to the old approach. We're having the constructor here. This is really easy to test. And the reason being is, if we're doing a feature test, a functional test, whatever you want to call it, when you're testing a controller, when you are actually testing the request, all the request lifecycle, if you don't want to actually have the gateway, if you don't want to actually call Stripe or call Braintree, you can swap this implementation, because this is resolved through the container. And it would be the same thing if you were using the resolve method here. But if you were hard instantiating it using the new keyword, saying gateway equals new blah blah blah, or using the factory as we had it, you wouldn't be able to do this. It would always give you a hard dependency. And that's really troublesome, because you wouldn't be able to test this properly. You don't actually want to hit a Stripe. What you could do instead is swap this for a fake implementation. Laravel uses it in another places. So if you go to bus fake, this is a class, and you can see that it implements queue in dispatcher. And you can see that it has the same API. So let me show you guys. It has the dispatch queue method. It has the dispatch now method. It has a dispatch method. And when you swap the bus implementation for this bus fake implementation, it does things differently. It is a different implementation. So you can see that we have this shoot fake job, and when it's a fake implementation, instead of dispatching, it actually just adds it to an array, and then you can check things like which job was dispatched, if it was dispatched after response. You have lots of ways to do this. But I'm starting to get confusing here. But what I want to say is, when you inject a dependency instead of hard instantiating it, you can swap it for anything that follows a contract, if it does follow a contract. And in this case, we are injecting an interface, a contract. So we are saying, hey, whenever you ask for this contract, give this class. And the Laravel framework does this in lots of places. You'll find it all over the framework. I don't think it instantiates a hard dependency anywhere. It always uses the container, and the container is very powerful. So if you would like to test this class, it's really easy in the way it is. You can just swap this implementation for a fake or for a mock. You can mock this, and Laravel will automatically give the swapped class instead of this one. I think that's it for dependency injection. I do have another video about dependency injection. It's a little bit old, but I think it does get my point. And yeah, so whenever you think about making a mask with a lot of conditionals, think about either using a factory or using dependency injection and the container. Most people don't use this, and this is a really powerful class. You can do lots of things here. So yeah, if you go to documentation, there are other methods, and you can do a lot of things. You can even be more extreme and say container. When the payments controller asks for a payment gateway, give it class A. But when the invoices controller asks for the same implementation, for the same interface, give it class B. I'm not a fan of this approach, but you can do it. You can run anonymous functions inside here. So you can actually run some code inside the function to determine which class to give. There are lots of things. And all I want to do with this video is lay some foundation and help you guys a little bit for the next video, which is about the repository pattern, which is widely used. It's a really common pattern, and I want to talk about it. And I actually want to talk about why I don't like it, what I have against it. And to do this, I need to give you some foundation on what is dependency injection, how it works, how the container works. And there's a little other problem here. We are assuming that Braintree and Stripe both return the same thing. So we're calling this and we want to do something with this payment. But truth is, most services will return different things. Most implementations will return different things. And if you don't want to end up with conditional how, the best way that you have to avoid it is to have a standard object. So let's say Braintree returns an array or returns a Braintree payment object, something like that. Instead of returning this, you would have the contract return something like payment, a payment object, which is a standard object that you can construct based on a Braintree response or a Stripe response. And you would always end up, regardless of the gateway that you're using, you would always end up with the same object, with the same class, with the same methods, and with the same properties. So let's say Braintree returns the invoice on an invoice ID field, but Stripe returns it on an invoice field. They are different fields. The solution would be put in an if block here. So I don't know, invoice ID, you could do gateway Stripe is a Stripe, something like that. And if it is, you'd say invoice, it would say payment invoice. If it wasn't, you'd say invoice ID. And that's just messy and confusing. If you were to return a standard object, you could just say invoice ID, payment, invoice ID. And this would be a standard object that both implementations return and construct based on the data it has. Even if we were to just change this to total amount and have it amounted here, it already breaks the whole thing. So I'm going to make a video on standard objects. I think it's really useful as well. And I think this video wasn't really good. I mean, I think I passed my point, but I think it got confusing in some parts. So if you guys don't understand something, please leave it in the comments. I would gladly help you guys. I also have a few blog posts about this. It might be easier to understand. But anyway, thank you for watching. I really appreciate it. And if you've liked this video, you can support me by subscribing to the channel or liking the video and sharing it with friends. If you could share, that's really helpful. That's the most helpful thing. So thank you guys, and I'll see you later in the next video, which is about dependency injection, and after that, standard objects. And that's it, guys. Talk to you later. Bye bye.